So this is the box that I use to control the water outlet valve on the absorber. So the more I close it, the more water I have in the absorber, and the more I open it, the faster the water flows through the absorber. And I control the load on the engine through here. Okay, so inside this box is an Arduino and the stepper motor controller. And this is attached to a encoder. And the encoder gives a pulse to the Arduino, and then the Arduino, you need the Arduino there so that you can tell the stepper motor which way you want it to turn. So turning that clockwise makes it the valve shut, and counterclockwise makes it open. Now what should be happening right now is that you should be seeing a number right here. And the number basically goes between 0 and 100. 0 means that the valve is completely shut, and 100 means that the valve's completely open, but it's not doing anything. And what it seems to be related to is temperature. It seems like it takes time for something inside of here to warm up. At least that's what it seems to be for now. But this switch here is meant to go between manual load control, which is controlling the load on the engine through this knob. But I want to work on, the other thing I want to work on, aside from fixing the other problems that are wrong with this, is maybe trying to work on the automated load control. And getting that to work would be really nice. It would make each dyno pull so much easier. It would make it easier to repeat each test. So like when I'm controlling it, one test could be the engine RPM ramp rate could be different from one test to the other, but if I can get that to work, it would make each test more repeatable. So, but I got a lot of work to do in order to get that functioning. But so for right now, let's just wait for this to let's see if this will warm up and wake up. And for just a reference, you can see that there's the absorber, and then there's those two hoses go into that manifold, and that aluminum block in the middle of that's the valve. And it's like I think if I remember right, it's a 50mm valve, and it's a butterfly valve type. And that to the right of that is the stepper motor, and to the left is a position indicator. And then there's that thermocouple where I measure the water temperature coming out, and then the water just drains into that tote. Alright, so I need to get that out of there because it's like the first week in January, and it's in the 30s in here, and it costs money for me to heat the garage up, and it's just easier for me to do this inside. So I'm going to take that assembly off of there, and then I'm going to take it indoors, and where I have a place to work on this type of thing and not freeze while I'm doing it. So let me get that out of there too, and we'll see. I can give you a better look at what's going on inside of that as well. Okay, so it's been plugged in for a few minutes now, and it's still not waking up and responding to the knob inputs. So I'm going to try warming it up with a hairdryer and see if I can kind of prove my case here a little bit. And down here on the sides, both front and top and bottom, there's some vents there, so I can push some warm air through this. I'm hoping you can see that number there. It's a 10. I'll try to zoom in on it so you can see it better. You can see after just warming that up a little bit, it's working a little bit. Now it's doing what it's supposed to be doing, more or less. Although it seems to me like sometimes it it doesn't do what it's supposed to do. It's not exactly responding to each pulse from the encoder the way I want it to, and I think maybe that's just... maybe it's not warm enough? And I'm kind of wondering, you know, I hadn't had this problem in the summertime when it was hot out, right? It just turned up in the fall. So it seems like there's something inside of there that is that needs to warm up. It needs to be warm enough to start working, and I think that is just kind of a strange thing to see. But I'm going to warm it up a little bit more, and then there's one more thing I want to show you. Okay, that should be enough. It's pretty warm to the touch now. But okay, and so the next thing I want to do is I'm going to put a little a mark on here so that you can see better the position of the knob. And then I'll try to give a slightly better angle. So like I said before, that when that reads 0, the valve is shut, and when it reads 100, the valve's completely open. And then the thing to know about a stepper motor is that it doesn't move in smooth, angular ways. It goes in steps, hence the word stepper motor. So it moves in increments like that. It's not like a smooth, angular change. It's these steps and angular changes. And so it's at 15 now, and you see it kind of goes up, and even when I'm turning the knob slowly, it'll go up in like 2 or 3% increments, which isn't... I think I might need a little bit more resolution in that. Like if I could get that to move up in 1% increments and down in 1% increments, that would give me better control over that valve and better control over the load that the dyno's putting on the engine, or the absorber's putting on the engine. So that's one thing I want to work on, get that resolution better. And then I need to find out, maybe that's just a matter of maybe that's the nature of the position indicator. Maybe it's not really that I have a resolution problem in my my stepper motor. Maybe it's more like, maybe it's just a matter of the resolution in the position indicator. And we'll be able to see this stuff once I get this stuff in the house where it's warm. I'll show you the way this stuff works and what I want to make different about it. But so if you can watch that mark there, so you can see where the position of this knob is, and then watch that. So I'm going to turn it this way and it'll open, right? But watch, it's at 30 now, right? And I'm going to start turning it back the other way because I want to close it. And what's it do first? It opens it up a little bit, right? And then it starts shutting it. And if you got something like that going on when you're trying to control the engine and you're like going back and forth, you know, the first step's going to be in the opposite direction. And then the next couple steps will be in the right direction. And that makes for a very difficult time controlling the load on the engine, especially when you need to just move it up or down one increment. It makes it real difficult. Okay, so that's the bulk of what we got to try to work on. And so let me get that, get all these components in the house, and we can start working on it then. All right, I got the load control valve removed from the absorber, and we're back in the house where it's warm. And I'll start taking this stuff apart and maybe get this valve off of here, or at least get that off of there, and then get that off. And that's just this is just a cover for the stepper motor, which is right there. So let me get it disassembled a little bit, and then I can kind of show you how the motion of the that valve that's inside of here. Okay, so I'm going to turn the knob now. I can't get the knob and I can't get the controller and the valve in the same shot, I'm afraid, but you see how it moves in increments like that? Now that thing that I was concerned about before where I showed you the it would move in the wrong direction before it moved in the direction that I wanted it to move in. Well, apparently that is just that's something with the that's got something to do with this position indicator. The actual movement of the valve corresponds with movements on that dial, on that knob on the controller. So that's not an issue anymore. So anyway, there's one thing I can scratch off the list, is that it's just something to do with that that position indicator, and I'm not concerned about that. As long as the valve is moving in the way that the knob is moving, that's what I care about. The display on the controller is more just like just to give me an idea where the valve is. It doesn't have anything to do with anything serious. You can see how it moves in increments like that. But what I want to have happen is I want each pulse from the encoder to make that valve move a smaller amount. How do I get that valve to move in smaller increments if I can't really do anything about what this is doing? Well, what I think I'm going to try and look into, move the stepper motor off to the side and put maybe either a belt, a gear reduction belt, like a cogged belt in here, between, have like a pulley on the shaft that goes through here, and then have a pulley on here, but have the pulley on the stepper motor be smaller than the pulley on there, and then get like a gear reduction so that each step or turn here would yield a smaller angular turn here and give me more resolution in the way that this valve moves. So that's one thing we're going to do. And then the other thing, I showed you that thing where where I turned this on and it was cold and it didn't work at all. And now after it's warmed up, everything's fine. So my guess is during the summer months, like the spring, summer, fall months, this thing will work just fine. But when it's cold out, something has a problem in there. Something's not happy in there when it's cold. So what I might try to do is, well, there's two things I could do. I could either go through a lot of diagnostics to find out what's causing that to happen, and maybe still never find out what the source of it is, or maybe I could put like a heating element in here someplace, and maybe a fan or something to control the temperature inside this enclosure. And right about now, that seems like the easiest way to deal with this. Okay, so here's what I ended up getting to control the temperature of the enclosure during the cold winter months. And what I got was this heating element here. It's got two wires, and then I got this, it's basically a heat element controller, so that you can adjust what the set point of the temperature is you're after. And it's got this, I don't know if that's a thermistor or a thermocouple, but that's the feedback for it. So I just need to get this mounted inside of, I think I'm going to put it here. So I'm going to have to make some parts to hold it in there, because there's nothing there to hold onto it with. And then I just need to run the wires out through the front of the enclosure, or the top of the enclosure, and then I need to make a mount for the feedback sensor, and I'll probably put that somewhere in the middle, I think, or maybe around in here. So let me do that. Let me get these parts made to secure this in here, and then we can and then we can try it out and see how well it works. Okay, so I just decided to go ahead and 3D print the mounts for that heating element. It should be done here in just a few seconds. And that's basically how it's going to go on there. Okay, so I got the heating element installed right here. Still need to get the wires connected, but the next thing I want to make a mount for is this temperature probe. So I kind of want it in the middle of the enclosure, but not really too much in the way of anything else. So I think right around in there ought to be good. And those, I did make those out of PLA, and it says on the heating element that it doesn't go above 120 degrees Celsius, which is kind of hot, but I think that holding onto it out here at the ends, they should be okay, but I'll keep an eye on them, make sure that material holds up. So let me get to work on the mount for that temperature probe. Okay, so I got the heating element installed, and I just got I made a 3D printed mount for that temperature probe, and I put it quite close to the heating element so that, well, I kept it close to try to keep the transport lag down. But anyway, and this thing does get pretty hot, and I'm just gonna have to keep an eye on it for a while and make sure that it's safe, and to make sure that these PLA printed parts are gonna hold up to that temperature. So anyway, I just need to be careful with it for a while and keep an eye on it and make sure it's all good. And now I'm gonna put the cover on it and move on. Okay, just to try to test things out a little bit here, I put the load control box in the freezer for a little while, just like 20 minutes, and yeah, and after coming out, the stepper motor no longer responds to inputs from this. But if I go into auto mode, the stepper motor is doing something when I go into that. So what that kind of tells me is that everything's okay from the Arduino into the stepper motor driver all the way out to the stepper motor. And that kind of makes me think that what the issue is what gets cold and has a problem is the encoder. So what I'm doing is I want to watch the temperature here, which is that that temperature probe that I put in there, comes in through here. And apparently it's gotten so cold it's throwing some sort of an error. It says E1 instead of a temperature. So I'm going to let it slowly warm up, just room temperature. I don't have the heater on yet. I'm just going to watch this and see at what temperature this thing starts to work again. Okay, so when I got to about 42 degrees on this display here, I know there's a lot of glare there, but anyway, when I got to about 42 degrees on here, the stepper motor woke up. Inputs from the encoder started making the stepper motor work. But now kind of what it's doing is it's moving when it's not getting an input from anything, which kind of acts sort of like it's got noise, or maybe there's a false signal coming out of this, and maybe it needs to warm up a little bit further before it starts working properly. So I'm going to let it warm up a little bit more and see if that false output signal clears up after a while. Okay, so what I noticed was when this temperature here got to about 49 degrees, and these temperatures are in Fahrenheit, of course, but when I got to about 49 degrees here, that false output, so that false output that it was getting, which was making the stepper motor turn when I wasn't giving it a command to through the knob. When I got to about 49 degrees, that really started to clear up. It does kind of look like it's a temperature related thing, and I'm mostly suspicious of the encoder. I think what this encoder is, it's an optical encoder, and maybe what's going on in there at the right or wrong temperature, depending on how you look at it. Maybe some condensation is forming on the optics inside of it, and maybe that's causing a problem. But really, for me, that's just a guess. I really don't know what's going on inside of that. What I think is that I think that the problem is in the encoder, and hopefully that by putting that heating element in there gives me some control over the temperature of the inside of that enclosure. So hopefully that problem is fixed. And like I said, I'm just going to keep an eye on this thing until I feel like I can trust that the temperature of that heating element in there isn't too hot for the PLA. That heat. So, but like I said, we'll keep an eye on it, make sure it's safe, and then we'll move on. But hopefully this problem here is hopefully this problem is better than it was. Unfortunately, that's all I got time for this week. And then next week we can start working on the gear reduction that I'm thinking about using to make each step of the stepper motor move the valve a smaller amount, and maybe get better control over the absorber that way. So, but that's all I got for now, and we'll see you next time.